Hey class, Absolute 5 here. So let's get going with this. So we're continuing part 2 of more formulas with differentiations, or just simply taking the derivative of our functions. So let's get right into it. We're going to talk about the constant multiple rule. The constant multiple rule, right? What this is just saying is if C is a constant and F is differentiable function, then we need a different marker. Then d over dx of c f of x, right? What this is saying is if you have a function but it's being multiplied by a constant, you're allowed to take out the constant and then differentiate inside to hit the function. So this way you're able to take the derivative of the function and not worry about anything else what's happening with the constant. So for example, if I gave you the derivative of dx times, you're differentiating 3x to the fourth. What's happening is this. You're taking out the 3, so the 3 goes in front, dx, x to the fourth. And then you're going to take the derivative of this. It will be 3 times 4x to the third. So then I multiply the constants here. So 3 times 4 is going to be 12x to the third. And that's how you normally differentiate something with the power rule. This can also go for polynomials, it can also go for trigonometric functions, even square roots depending on the square root. But yeah, that's for the constant. Now there's also, does this also work for the sums and differences? Of course. Differentiation works wonders on many things. Many things. So the sum slash difference rule, that's what this is called. So it states if f and g are both differentiable, then when I differentiate both the two functions, f of x plus or minus, you can do either one, of g of x, you simply get d over dx f of x plus or minus d dx g of x. So in a sense, you're distributing the differentiation, the derivative, to both the functions at the same time. You're doing it, you're literally distributing it. So the derivatives are just, you're able to use the distributive law with that. So we're going to write an example of this where we apply, let's use this example real quick. Let's just use this example real quick. So you're allowed to distribute the derivative into a long polynomial. So let's use the example here. x8 plus 12x to the fifth minus 4x to the fourth plus 10x to the third minus 6x plus 5. Okay. So when we differentiate this, right, it's going to be d dx parentheses x to the 8th plus 12x to the 5th minus 4x to the 4th plus 10x to the 3rd minus 6x plus 5, parentheses, close. So we're going to do exactly what the formula told us to do. We're going to differentiate each and every single term. Plus 12 d dx x to the 5th minus 4 d dx x to the 4th this is to the fifth, sorry. Fifth, this is the fourth. 10 d dx x to the third minus 6 d dx x plus d dx to the fifth. So, when we differentiate this, right, we're going to get 8x to the 7 based on the power rule that we learned yesterday. 12 times whatever the derivative of this is, so it's 5x to the fourth, minus 4 times 4x to the third, plus 10 3x squared minus 6 times 1 plus 0. Why is it 0? Because the derivative of a constant is always 0. Remember, the constant function is always 0. It has 0 slope. That's why any constant, you take the derivative of it, it's 0. So, with some basic algebra, you're able to get 12 times 5 is 60, x to the fourth. Negative 4 times 4 is negative 16, x to the third, plus 30x squared minus 6, and that will be your answer. So, you see how I differentiated every single term. You don't necessarily have to write this entire line. I was just exaggerating, but it's always good to see how it's done. So then when you get really good at it, you can just look at it and just say, oh, this is 8x to the 7, this is 60, and you can just look at the numbers after a while and figure out, okay, this is this is that. But in the beginning, I stress that you start off doing this way first, eventually skipping this step, and then you get to this part, and then you work everything out, and then everything should be fine. Just be very careful with the signs, because I know a lot of people have trouble with signs. So we'll talk about that another time. So that's the video for you guys today, lesson more or less. And I hope this has helped a little bit when it comes to differentiating these types of functions. We'll definitely talk about more in the near future. So like, share, subscribe to this channel, and if you like the content that I give, be sure to hit the bell button next to the subscribe button. If you have any questions, please leave me any questions down below, down in the comments, or even on my other social medias. And that's basically it. So this has been Absolute 5. I'm Roger Palomino, and math is infinite because there are infinitely many possibilities. Oh yeah.